I put this piece of Alpha Munitions brass through hell, literally. The torture test was surprising. How many shots was this piece of brass able to withstand? Watch the video to find out. Gavin here from UltimateReloader.com. First and foremost, I want to start this video by saying, don't do this at home. We're going to show you some stuff and talk about some results, including some from a prior video that you should just not attempt. I've got experts involved here, a lot of guidance, analysis, data, math, and have taken a lot of precautions. Okay, this video is really an extension of the story we started last time with Bruce Tom from Bat Machine. We built a rifle, I chambered a rifle in .308 Winchester, and we put it through its paces, pushing it to really, really high pressures, basically taking it into the 300 Win Mag territory. I want to cover that briefly and then segue into our torture test of this brass, where it repeatedly fired a max load .308 Winchester load, and we took it to the point of failure, right? With no annealing in between, a true torture test. Okay, so stepping back, the high pressure experiment was all about seeing how high we could go with pressure and not have adverse signs with the case. And what was really surprising was we started just under max and we successively increased the charge weight until literally we were 67% over semi max. You should never do that. Bruce Tom, the guy that I was doing the test with, the owner of Bat Machine, has done destructive testing on actions and knows exactly what to look for. So to look at it in graph form, you know, we've got .308 territory, we've got 30-06 territory, and we've got 300 Win Mag territory. And we came very close to max charge velocities with Alpha Munitions small rifle primer .308 Winchester brass. Absolutely astounding results, and the brass did not fail. So Alpha Munitions has their optimized casehead design technology, OCD brass, and we proved that, you know, this brass can hold up to the pressure. And one of the things that Bruce commented on was he's never seen primer pockets hold up beyond about 80,000 PSI, right? And we took it all the way up to just over 100,000 PSI, which you should not do. And we did not blow any primers, which was really, really amazing. But we did start to see some cratering and some signs before the signs, if that makes sense. So that project was really interesting. And, you know, Bruce had never seen those kinds of results before, the brass holding up to this kind of high pressure and not failing. But how many firings can it take? I've done limited testing of this type in the past. I think for 224 Valkyrie, if I remember correctly, I had 13 firings maximum from a piece of brass before I saw primer pocket deterioration to the point where the brass was unusable. And you know what happens is if the case head isn't strong enough, it just kind of yields over successive firings and it just can't hold on to the primer anymore. You'll blow primers, you'll get other primer, you know, signs and problems and piercings, you know, things like that. And so, you know, as a natural extension of the high pressure testing, I wanted to go through a prescribed process. This is kind of what I decided to do. I didn't have enough of the Berger 215s that we used last time, so I substituted Hornady 212 ELDX bullets, right? Same basic weight class. I went to Hodgson's website. I looked up the load data again for .308 Winchester, and I saw a max load of 41.3. Right? This is a little bit above where we started last time with the high pressure experiment. So I decided I'm going to use the max charge and I'm going to reload the case each time, but I'm not going to kneel, right? So for each firing, I did photography prior to, like basically as it came out of the gun before resizing it, of the side and of the head stamp area. And then did sizing and depriming. I'm using the Area 419 Zero Press. I've got the M series dies here. This is the .308 Winchester one here. Same exact settings that Bruce, Tom, and I put together for this. Sized it, deprimed it. I was very careful not to overwork the brass. So the sizing and depriming gets ready for the priming. Use the competition primer seater to seat federal small rifle primers. Through the charge, and I was just using a Hornady lock and load bench powder measure. I saw about plus or minus 0.1 grain, which was plenty accurate for this experiment. So I was at 41.3, might see a 41.2, 41.4, you know, just generally in that range. It's a good powder measure. Seated the bullet. I've got, I think, a Redding die here on the zero press for that, and then would go and fire it in the rifle. And so I recorded each of the shots. Small rifle primers tend to hold up better under high pressure scenarios, right? You've got a little bit less surface area, so there's less forces, but also the case head is thicker when you have a small primer in a case head that was designed to accommodate large rifle primers. It's just thicker, right? So it's a good way to go there. 41.3 grains of Hodgdon Varget, the max load, Hornady 212 grain ELDX bullet, and Federal small rifle primer, right? Do not use this load data. Always go and look up multiple sources of OEM's published data, like this data from Hodgdon, to make sure, and always work up below max load. We already went well above the max load. Don't do that either. So this is where I started for this particular experiment. A little bit about the rifle. So it was built with a bat igniter action. We've got a ballistic advantage barrel blank that I chambered with a Precision Matthews lathe and an Alpha Munitions Legacy reamer with 0.096 inch freebore. That's the shorter of the two. I think they have one that's 212 is the other one. It's a solid carbide reamer. Foundation Centurion stock, Hawkins Precision M5 bottom metal. Love that bottom metal. It works super well. Loophole Mark V HD scope and EC tuner brake. It's the same exact rifle configuration that we used for the high pressure testing. What I want to show you next is the succession of all of the different shots, and then I'll talk about what happened. So this was pretty amazing, I'll have to say. The brass held up to 47 firings at max charge with no annealing, and it did develop a crack in the case neck. When we look at the velocity data, you'll see something really interesting related to that I didn't expect. Primers retained for all 47 shots. This last one, very, very slight cratering, right? So there might be a little bit of movement of the primer in the primer pocket, but still functional, right? That's why this is tipping a little bit on the table there. Just a little bit protruding between the firing pin and the firing pin hole in the action. One of the really interesting things was I totally forgot about trimming. I've been shooting so many rifle cartridges that don't really require trimming with a sharper shoulder angle or brass that I'm not shooting 10 times, you know, that sort of thing. I got to shot 30 and I realized I'm feeling just a little bit of something there as I'm chambering it, right? And so I took a measurement and the brass had grown from 2.007 inches, which is the factory spec, to 2.037. So about 30 thousandths of an inch elongation over those 30 firings. So that's an average of 1,000th of an inch per firing. That is not a lot. This brass is incredibly stable. So after the 30th firing, I trimmed it down to just under a couple thousandths under what the new brass was at, right? So I trimmed it down to 2.005 inches. And between shots 31 and shot 47, the brass grew to 2.016, which is still plenty functional. So I was really surprised that more trimming wasn't necessary and just how stable this brass is. The brass just, it really does not flow much at all, if at all, right? I mean, that's a very slight amount, 1,000th of an inch per firing on average. Really impressed with that. Okay, so that was one thing. And then the other interesting observation is when we look at the velocities of all these shots. I think I missed one shot with the chronograph, so we have 46 shots total. And you can see there was initially a little bit of a rise, and then things kind of maintained a very consistent velocity, right? So I've enlarged essentially the range of the graph to show just the variation, right? If you look at the total velocity, it's hard to even see it move from 0 to 2500. But when we go from 2470 to 2520, we can really see those variations a lot more in terms of extended height on the graph, right? We had an average of 2497.9, which is well over what Hodgdon predicted. That's interesting. We had a standard deviation of 7.5 feet per second over 46 shots and an extreme spread of 37.4. A lot of that extreme spread was between shots 1 and 2. And then, so we saw what looks like a trend line of steadily increasing velocity between shots 1 and shot 14. And then it just kind of maintained that sort of average of just over 2,500 feet per second after that point. Overall average of 2497.9, right? Call it, basically it's 2,500 feet per second, which is really impressive. Especially since Hodgdon's data with the same barrel length of 24 inches shows 2,399 feet per second, right? So we're basically 100 feet per second over what the low data would suggest. That is impressive. Okay, and if we carefully analyze the photography, I didn't notice this case split until basically after shooting shot number 47. I had a little bit of carbon on the neck there that was kind of obscuring it. It looked like a mark from just being pulled out of the die with some carbon, right? Nope, there's a pretty healthy split there. The crack actually was developing between shots essentially 31 and 46. And what's interesting is we didn't lose a lot of velocity there. The velocity trend continues just like it was between shots 14 and 30. I kind of would have expected something a little bit different there, maybe like a reduction in velocity with the gases blowing by or something like that. So that's really interesting. And in talking with Alpha Munitions, they're aware of some testing that Greg Dykstra from Primal Rights did, where he got up to 100 firings out of a case when he annealed between each firing. And that makes sense. I'm work hardening the case neck area really bad there. And it makes sense that after 30 firings with no annealing, that we would have a crack developing there. So it makes me wonder what would have happened if we had annealed, right? I use the AMP annealer. Thing is amazing. It's incredibly consistent. It has its analyze process where it can basically determine the optimal annealing power and duration, all the settings, right, for the machine. That might be an interesting experiment to do. No, this experiment took a lot of time, right? Photographing between each shot and doing the loading each time, a few minutes at least between each shot to do all of that. And so, over 40 shots, that's a fair amount of time, plus all the setup and other supporting, photography and video B-roll. So who knows? This could be an all-day deal if you were annealing and you're using Alpha Munitions brass. Kind of interesting. The other aspect I think about the Alpha Munitions brass that's notable is the precision that we get out of our reloads and our loads. My most accurate group I've ever shot was with one of the rifles I built. It was a 6-dasher. With Virgin Alpha Munitions 6-dasher brass, we had this .090 inch 5-shot group that I got on camera. I had a target camera going, a firing line camera, and you should check out my 6-dasher load development video if you want to check out that whole sequence in detail. But this has been a consistent pattern. Low SDs, very, very consistent internal case capacity, great longevity, and really good groups with the rifles that I've built, and have subsequently loaded ammo with Alpha Munitions brass, for. So I'm really, really impressed. I think Alpha's really onto something with their processes, their OCD, optimized case head design, metallurgy, and just, everybody that I've talked to that uses Alpha Munitions brass is a huge fan of it for the reasons that we've shown, right? This is data-driven analysis. We do these experiments, we show you guys the results, and it's kind of up to you to conclude if this is something that you're interested in purchasing and using, right? This Alpha Munitions brass. And the reamers, and that's part of that correctness formula, right? So, You've got the chamber in your rifle, you've got the chamber in your reloading die, your sizer die specifically, and then you've got the brass itself. And what SAAMI specifies for those ammunition and chamber specifications need to be incorporated across the board for this type of result. You know, you're not going to get this if you've got excessive room in your chamber. You're not going to get it if your die dimensions aren't correctly, because you're going to be overworking your brass. You're going to run into bolt lift issues, sticky bolt, clickers, that sort of thing, right? So it's really important to look at the big picture and align all of those factors, what we call the correctness formula, kind of across the board, right? And the Alpha brass, it can withstand very high pressure. It has the best longevity we've ever tested, like 3 times the longevity, basically. And the primer pocket never failed, right? So it's possible that with annealing, we could have extended that greatly. And the precision has been awesome. So I'm a huge fan. My question for you is, what have your experiences been? Are you using Alpha reamers to chamber rifles? Are you using Alpha brass for varminting or for PRS matches or for F-class? Tell me what you're doing with it. Have you done any kind of torture testing? What have your results been? Drop a comment and we'll start the discussion. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you want to learn lucrative gunsmithing like what I show here on the channel, including building custom rifles and Cerakote plus a whole bunch more, you're going to want to check out the Colorado School of Trades, schooloftrades.edu. Thanks again for watching.